Kubernetes. So I'm on the Kubernetes documentation right now, and according to me, the best way to learn some new technology is to just learn from the documentation itself, as that is the use of that is the use of it, right? So let's see what the documentation says. We have Kubernetes is an open source container orchestration engine. Now, if you have watched my Docker video, you would know that a container is nothing but it's just a box that has all the required files in it that you would need to run your application on any other device without any problem. So it is still doing something with container, okay? It is orchestrating it. Orchestrating means it's controlling different containers and managing them at the same time. Now inside Docker we created single containers, but inside Kubernetes you can create multiple containers, and you can create like a lot of containers. So Kubernetes is just a more production level technology. So it is for automated deployment, scaling, and management of containerized applications. The open source project is hosted by Cloud Native Computing Foundation (CSCF). These guys are awesome. They have created many cloud related programs. They have some graduated projects, some incubating, and some sandbox projects. Argo CD, Karmada, Litmus, HubeWord, Caverno. These are all like really good projects. Okay, so let's move on and understand how Kubernetes works under the hood. So we must understand how it works, right? So Kubernetes has something called a cluster, and inside this cluster, there is everything else. Okay, so the first thing inside it is the control plane, which you can understand as the brain of the complete cluster. Okay, or you can also call the control plane the master node, and these are the worker nodes. The node 1 and node 2 are the worker nodes. Inside control plane, there is a thing called Kube API server. This Kube API server, you can think of it as a okay, let's say control plane is our loading bay for a shipyard. Okay, so Kube API server would be the crane operator, and all these different components that are inside in the control plane would talk to the Kube API server. They would like, okay, I want to move this from my own system, and he wants to move this into their system. So Kube API server will gather all of that components that it wants to move, and then it will talk to the nodes. These nodes are singular ships. Okay, so the crane manager would talk to the ships, and it will be like, okay, uh, we have these components and these files that we want to transfer to you. So Kube API server will transfer them to the node and to another node. So this is how the control plane and the master node worker nodes work. Okay, so let's understand what are inside the control plane then. So we have understood Kube API server. etcd is like a storeroom, and inside the storeroom there are values that are stored in the form of key value pairs. So key value pairs are like this. So we have some data: name Varchasv, age 21, and location Noida. So how key value pair works is, these are the keys on the left hand side. Name, age, and location are the keys, and these are the values that are associated with their keys. So when we call name, Varchasva would be given. When we call age, 21 would be given. When we call location, Noida would be given. So etcd is nothing but just a storeroom for these kind of values. And scheduler is used to schedule pods inside these nodes. So these there are some thing called pods. I will get to them. And scheduler basically schedules pods inside the nodes, and control manager controls different kind of things. For example, if you want to replicate new pods, or we can create deployments, everything is managed by controller manager. uh, After this, let's move on to the node. Inside the node, there is kubelet. So when we were inside control plane and we were talking about Kube API server, I told you that he was like the crane operator who was talking to someone inside this node. So Kube API server was talking to Kubelet. Kubelet is the captain of the ship, and everything that we want to have on the ship will be taken from the Kube API server, and they will go through Kubelet. The same with the second node. Inside this node, there are also pods. Now, pods are the smallest deployable unit. Inside these pods, there are multiple containers inside them. So, in Docker, there were one container, right? There were only one container at a time. Inside these pods, you can create multiple containers, and you can create then multiple pods inside a node. So, Kubernetes is just what Docker was doing, but on a really grand level. So, yeah, that was it. And let's jump inside our demo. So, for our purpose, as we are just trying to learn, we will be using Killer Coda Playgrounds. Killer Coda provides free Kubernetes playground that you can like learn basically. Okay. So I will press start and I can create, let's start by creating a pod. Okay. So we can do pi pod.yaml. This will create a file called pod.yaml. So I will press enter and it will open an editor. I can press I, and now I have to write what version of Kubernetes we are using. So we are using the V1 API. Okay. After this, we have to specify what kind of component in Kubernetes are we creating? Are we creating a deployment? Are we creating a service? Are we creating a pod? In our case, we are creating a pod, so we'll just write pod, and then we can write metadata, which would include some values about the pod. It is really not necessary that you need to provide many things in this. You can name it. If you don't name it, then the pod that will be created will have a random name. So let's name it my app pod. And then the main thing is the spec. Spec or specifications contain all the different values that we need to give the pod. Okay, so first we have to define that we want to create a container, and inside this we will do the name of the container is, for example, if you want to run a nginx web server, so we can do nginx web server, and then we can provide the image. So the image will be pulled from the Docker hub itself, so we can just provide nginx, and that's good. We can also provide what kind of port we want to listen to or listen on. So we can do ports and the container port 80. So we can save it by wq, and the command to make any kind of deployment Kubernetes pods or services is just kubectl apply, or you can write create instead of apply. You have to do /f file name pod.yaml. When I press enter, it is saying that my app pod was created. Okay, that's fine, but how do I see if it was created or not, or if it's running or not? So what you can do is you can type kubectl get pods, and we can see that the my app pod is ready and it is running. So let's see, we can go to our local host and we can go to 80, and we can see that the Apache 2 Ubuntu default page is loading and it is telling us that it works. So that's fine. Okay, so we understood what pods are, but I was also talking about deployments and services. What are those? Okay, the best thing is go to the documentation and type deployment, and we can go to the first one. It is in Chinese. You can use Google Translator to translate. Yeah. So a deployment is a pod. Uh, there is something wrong with this. Okay. You are responsible for describing the target state in deployment, and the deployment controller change the actual state to the desired state. So basically, deployments are used to declare pods and replica sets. Now, replica sets are, let's say we have a website. This is our website, and let's say it was a festival website, and there were many people coming to this website. The traffic was really high. Now, what would happen is if the traffic was more than the capability of this page, then this page would crash. To prevent that, we actually have to scale the pods, which means that there is only one pod running right now. We can increase it to two, or we can increase it to three or four. Now, to do that, we need to create a deployment. So we can type vi deployment.yaml. We can just go over here, and it is telling us that we need to specify API version apps1, the kind deployment, and we can provide the name. Labels are basically to label it. So it has, if you create it with using this, then it has a label called app or nginx. We can specify replica selectors. Basically, these selectors would match them. And then the main thing is the template. Isn't this looking really similar to the pod that we just created? Yeah, it is, because it is the same thing. Okay, so we will copy this, and we can actually, um, instead of writing our own, we can just copy and paste it over here. We can go right tap and paste. So after saving the deployment, we can just go kubectl apply /f and deployment.yaml, and this will create the deployment, and we can see it by using kubectl get deployments. Cube, uh, I forgot to write the L. So kubectl get deployments. There are 3 deployments that are up to date. Okay, that's fine. Now let's go. Let's all see the kubectl get pods, and there should be 3 pods that are running through the nginx deployment, and there are 3 pods that are running through the nginx deployment. After this, we also have something called as the services inside Kubernetes. A service is a method for exposing a network application that is running as one or more pods in your cluster. Basically, we can expose a network application on our pod, right? So they will also provide us with an example. There are different kinds of services. We can see service type over here. There is a cluster IP, node port, load balancer, external name. So to create a service, we can just go to ChatGPT and we can write, give me a basic service for Kubernetes, right? And we can go, and it will give us a basic service, right? So this is the deployment that it's giving, and this is the service that it wants to connect with. Okay, so let's copy this, and we can do vi service.yaml, and I can just paste it over here, no problem. Paste it over here. We have API version v1 kind of service, and we have named it nginx service. The app is nginx, and there's a protocol 8080. So that's fine. We can just do this, and let's do kubectl apply /f service.yaml. So the service was created. Now we can see all of the things that were created by typing kubectl get all. We can see our pods over here. We can see the services over here. We can see the deployment over here, and we can see the replica sets. So you can also scale your pods up and down. So there are only 3 pods that are running through the deployment. But if I wanted to increase the pods, I can just do kubectl and scale replicas is equals to, let's say I'm making 5 replicas or 5 pods. So we can do 5, and I can specify the deployment that I'm using, and can type nginx deployment. So it is telling us that the nginx deployment was scaled. Okay, let's see. We can go kubectl get all, and we can see there are 5 of the pods. So let's say our network traffic was really high at some time and we wanted to take more traffic. Okay. So we can just scale the pods up and we would be able to handle more traffic. But what happens when we don't have that much traffic again? Do we just have to run with all of these? No, we don't. We can just do kubectl. Like you can write the same command, right? And you can just decrease the replicas. You can do like two, and then it will create two replicas only. So this is done using replica set. This is a controller, right? So I think that's all you need to know about Kubernetes when you're just learning about it for the first time. If you are still confused, you can just search up to Chat GPT. You can ask Chat GPT, or you can search in Kubernetes and everything, right? So that was it for this video. And if you have any doubt regarding it, you feel free to ask me in the comments, or you can contact me on LinkedIn, Instagram, or any other website. And please subscribe if you are liking these videos. And I'll see you in the next one.